TelecomTV and episode 2 of a Two Pint Problem. So we're in London, Baker Street, and the reason this series is called a Two Pint Problem is because Sherlock Holmes, when he had a difficult time, he had two pipes at a time. It was a two-pipe problem. We're going to have two pint problems, and hence our homage to Sherlock. I'm here with Ian Scales, Managing Editor of TelecomTV, and Martin Taylor, CTO of Metaswitch Networks. Welcome again, lads. We were talking last week about network transformation, and we got part way into what is a very long and complex subject, and we got as far as a programmable network and way in which some standards are playing into this and others aren't, and so on. And I wanted to kick off this week, and I want to start with you on this, Martin, again, if we could, please. BSS OSS is generally a mess because it's this mass of spaghetti, as it were, on a huge plate, and you pick up one and you don't know where the other end's going to be. It's just grown exponentially. Nothing works with anything else. Nobody's quite sure what it is. It's always been back office, and therefore it's been hidden in the past. So what about BSS and OSS? Doesn't that have to be sorted out before we can have proper SDN and NFV?
Well, certainly in most telcos, that area of the network and the software around it, it has kind of accreted in layers for probably as much as two decades. And of course, it's very much oriented towards a traditional way of building networks, where a network was a collection of boxes, and boxes had all sorts of bits of proprietary hardware in, and any individual piece of hardware, like a circuit pack, for example, could go wrong at any time, so you needed to be able to generate alarms and all that kind of thing. And of course, the process of rolling out the network involved a box by box integration between those devices and the OSS systems for managing them. That's just not the way that networks are going to be built anymore, as we discussed last week.
Yeah.
We're talking about totally standardized hardware. So once you've decided on, you're going to buy servers from a particular vendor, maybe some white box switches from a particular vendor, that's the hardware taken care of. Yes, you're going to need some alarms and stuff. I mean, you need to know whether a server's overheating or its fan has failed, but that's the same for all of your network infrastructure. The OSS then obviously has to take to deal with some of the software management requirements, performance management, for example, where we want to know if there are software faults. We want to know how much work our network's doing, how many concurrent calls there are, and all that sort of thing. So yeah, we've got to gather a large amount of data, and of course, in a virtualized environment, what you're gathering the data from looks very different. So again, instead of having physical boxes that are emitting performance statistics, you've got all these virtualized network functions. And in a scale-out environment, you may have many virtual machines all hammering away in parallel, all generating their own performance statistics. Something has to collect all that information and synthesize a kind of service-level view as to how the service itself, that's what the telcos worry about. Is my service performing? Is it behaving properly? Yeah. So again, the traditional OSS BSS just doesn't know how to do that kind of thing. But there are all sorts of analytics packages out there which are perfectly capable of absorbing large quantities of streams of data and analyzing, and the sort of the big data thing, if you like.
Yeah.
So it really is about taking stuff that is happening in the IT space and applying it to the network. And there's all sorts of stuff there that's appropriate and suitable for building, if you like, the next generation OSS. It doesn't have to come necessarily from the traditional OSS vendors. We are talking about, really the thing about NFV is it's all about applying stuff that works in the IT space and adapting it for the telco network.
What do you make of that, Ian?
Well, it is. That's very interesting. And the thing that strikes me, and this is just an impression I've picked up in talking to people, is that what people may be worried about on the telco side is, as you say, you're virtualizing everything and you're putting it under one big umbrella. And it really just a very obvious thing is that what if it all went together? What if it all went over together? As you've got it at the moment, of course, you've got all of the different individual components, which in your imagination, in your head, you understand they sort of operate independently, don't they? And they report back to their own management system, and they're controlled through those statistics that you talk about. You synthesize them at the end. But if something really major goes wrong, you know which component to go to fix. And I think the nightmare that telco managers probably have is, what if we woke up one morning and there was some software bug right in the virtualization software that we hadn't noticed before, and we just had no way of knowing how to fix it?
Yeah, it's certainly
Nightmare scenario.
Yeah, it is a worry in the sense that, I mean, having a physical box that you can kind of go to is a sort of comfort blanket, I suppose, and you've got to be prepared to let that go and trust that your environment is sufficiently robust and resilient.
I was 17 before I let my blanket. Maybe that says everything.
But do you think that is in the back of people's minds? Do you think
Of course it is, and certainly, I mean, we've seen in the transformation from TDM to IP generally, there are things that can go wrong with the IP infrastructure. You know, you are very much reliant on the IP infrastructure. You know, we tend to treat the IP infrastructure, you know, as a business that's primarily focused on services. We just accept that it's there.
Yeah.
It's there all the time. Now, it has to be robust, and we lay down guidelines as to, you know, latency and fault tolerance and so on. But there are things that can go wrong, and technicians can, you know, misapply a configuration change or a software update to a router, let's say, and things can go catastrophically and horribly wrong. And you have to design your IP network in a defensive way, if you like, which protects you against that. The great thing about virtualization is that you can, there are all sorts of techniques that you can apply here, which again are very common in the IT world, which give you recovery scenarios from any kind of disaster you can think of. And you know, there's a heavy emphasis on geographic redundancy. So, you know, you're running a service in a way that's distributed across multiple physical locations. So if you lose an entire physical location, either from a natural disaster or, you know, a backhoe goes through a fiber and cuts off all network connectivity, stuff just carries on somewhere else. And hardware capacity is so cheap now that you can afford to have you know, spare capacity in the network to cope with those kinds of disasters.
Yes. And do you think that's something else that they've quite gripped, you know, that instead of having 5 nines in a particular box, there's 5 nines when you talk about
that is
system.
exactly the point, yeah. So, I mean, one of the discussions we have with telcos about this is, you know, they worry about the physical reliability of the servers. And we just say, forget it, because if a server goes down, the worst that ought to happen is you get a very modest reduction in the capacity of that service. But and typically you make sure you have enough headroom to allow for the failure of a physical server, or maybe even, you know, a top of rack Ethernet switch, for example. That might take out a whole bunch of servers. Well, if you've got a data center with hundreds of them in there, with a little bit of spare capacity, it just doesn't matter.
Yes. And that's the lesson learned from, you know, things like Google's huge cloud deployments and so on. That you don't even go in and change the server; you just leave it till the end of its life.
Well, and change when was the last time Google search went down? I mean, you know, it has done.
But we hadn't noticed.
Well, there you go. So, I mean, there's absolutely a perception that those services are just always there.
It's a little bit analogous to RAID, isn't it? You know, RAID is the redundant array of inexpensive disks. Well, this is a redundant array of inexpensive servers.
Indeed.
Raise.
Raise a glass to that.
Let's go back to where we were a bit before. We talked about last week, we scratched the surface of the standards issues, and I want to get back to BSS and OSS. I've seen for myself that there are now 2 opposing views emerging from within the industry, one of which is they're saying, well, look, we've got de facto proprietary standard, let's stick to it, and others want to tear up the status quo completely and start again from scratch, and to have a sort of new universal BSS, OSS standards to be devised, to be debated, to be ratified and adopted. Do you think that potential fight, and it is looming, could affect NFV and SDN and delay it?
It could. I mean, it's certainly true that you know, we talked before about how easy it is to experiment with new services by just deploying new pieces of software on the network. That makes it sound almost trivial. But of course, there is the requirement to manage that software, and you know, when you deploy a new piece of software on the network that delivers a service, it is a network function. You might not have to worry about the hardware aspects of it because that's all standardized, but there are still software things that you need to instrument. You know, you need the performance management, you need to be able to configure the services, you need to know when things are going wrong. So there is always some per-service integration effort that you need at the level of OSS and BSS. However, it could and perhaps should be a lot easier than it has been in the past, because typically, when you're talking about these new service software capabilities, they expose RESTful HTTP style APIs, web services style APIs, which are way easier to integrate with than the traditional TL1 or whatever sort of standardized command line interface these old boxes used to have. And the software techniques that are available are just way more adaptable. You can describe a a API, with the appropriate metadata to begin, like an XML document, and just hook into it, in a matter of hours or days to integrate with some service management API. Now, that isn't going to happen if we stay with the traditional OSS BSS. So there's no question it's going to need something new in that area. And I think there are big open questions around this. Who's going to provide those new systems?
Yeah.
Is the IT world going to step up a little bit here? Are the traditional OSS BSS vendors? What are their thoughts in this area? There's not much in the public domain about this now, but it's certainly going to be a factor, no question.
With NFV and SDN, there might even be the question: is there such a thing as OSS anymore? Because remember, it was about operations, and the basis of it was there was a man going somewhere with a screwdriver to do something, or at least to type in a command line on a Cisco router. That whole idea will go away to a certain extent.
Absolutely. Certainly all the hardware aspects of OSS just go away.
Goes.
Absolutely. It then just becomes a question of dealing with the software side of things. Now, again, in a lot of cases, a piece of software that delivers a service will come with some kind of a GUI for configuring it, and a web GUI. So it may just be a case of training the operators to use that GUI instead of having to plug into some very traditional, creaky, old-style OSS BSS system.
And when something goes wrong, it automatically fixes itself and then tells you about it later.
Well, that's the other thing. Your worries about alarms. So many of the alarms that you're really concerned about are purely hardware alarms, and again, as we've discussed, all of that is kind of standardized.
Yeah.
Software alarms, again, they're important, but again, if a virtual machine which is part of some service chain in the virtualized world, if it fails, then the entire framework needs to be designed, or should be designed, so that it doesn't matter. The whole system just carries on, because we're in a massively redundant scale-out kind of environment.
Yeah. So what I wonder, Martin, is what happens when, and at the moment we're kind of looking at our virtual things, aren't we? So we understand what the things do, and we're talking about managing virtual versions of them in the network, and we can understand that, and we know how to manage it, we know how to measure it, and all that sort of thing. What happens in the next phase, when instead of things they morph into something else? They're no longer. The great thing about a network is that you can map it in your head, and you can see all its metaphorical, all the metaphorical objects and what links everything. So you can imagine how you're going to change it, or you can imagine how you're going to manage it. But when it becomes very, very abstract, doesn't that get to be a difficulty?
I think it can certainly take people out of their comfort zones temporarily. But the fact is that you can still see these objects there. You can go to your OpenStack console and you can see the various functions that are effectively replacing the physical boxes. And you can still interact with them much as you would with a physical box. Typically, if you want to look at what's going on in the physical box, you log into it in some way, or through a command line interface or a web interface. You're going to do exactly the same with your virtual machine. So from a user perspective, it isn't that different. You're still talking to a device through a console of some kind. The fact that it happens to be a piece of software that's floating around in a cloud doesn't really make that much difference.
So you've got your icons on your desktop, and you kind of see the world like that as we go through our own desktops. I suppose we see the world like that, which is virtual, I suppose.
Sure. So the network diagram doesn't map to a collection of physical objects; it maps to a collection of virtual machines, and those virtual machines may not be one-to-one mapping, if you like, from the physical boxes that they replace, but they're still real.
And that brings us to how complex it's going to be for people to transform themselves from being OSS BSS OSS operatives in particular into this new world. That's going to be quite a wrench.
There's definitely going to be some new skills that need to be.
Do you not
acquired.
think it's, going from being a draftsman with your blueprints and all the rest of it to being Jackson Pollock?
Oh, not that messy.
Just very, very briefly, do you think, Ian and Martin, what comes first, do you think, as this transformation continues? Is it the business model or is it the programmable network that might define it? Martin?
They go hand in hand, of course. The telcos that we talk to are convinced enough about the value of doing this that they're kind of developing the business model in parallel. But I think that the top line view, when you just look at all the advantages that you get by making the network this soft and this adaptable and this programmable, and you look at the costs of doing it appear to be very manageable. The skills that you need, there may not be the exact skills you've got in your organisation right now, so you're going to have to bring in some new blood, there's going to be some retraining going on, but it all looks quite manageable. And the pressures that the telco industry faces right now are so great that they're not waiting for a detailed, analytical, traditional, this is going to be a 2-year return on investment kind of a business model analysis. There's an act of faith, but it's an act of faith which is, it really isn't, you don't need a lot of faith actually to
go with
just believe it's the right thing to do. Absolutely.
Okay.
Good note to end on. That's it, folks. We've got some beer to drink, which we shall continue to do. Thanks for watching. Cheers for now.